Okay, let's go ahead and check out the first part of ionic compounds. So the very first thing we're going to do is talk about naming and writing ions. So there are two key things I want you to be able to do here. The first one we've already done, but we need to bring that back from our atomic structure unit, and that is to determine the standard ion formation of groups 1, 2, and 13 through 18. So those same ones that we were looking at in our atomic structure section where we skipped over those transition metals. So we're still going to do that again, but we're going to dive a little bit deeper into that. And the second thing I need you to be able to do for this first part is to translate between an ion name and an ion formula. Which ion formula sounds kind of weird, so what I mean here is an ion name, maybe something like a calcium ion, and the ion formula with that would be a Ca+2. So name and formula, and that's going to be something you're going to be hearing a lot in this unit. So just start to get that little bit of vocabulary into your mind. Now I listed some of the vocab terms, some of which we know, some of which we're not familiar with yet. Valence electrons, we talked about those. Ions are charged particles here. Remember, cations are positive, anions are negative. Pattern metals we're going to get into, but those are going to be, our groups 1, 2, and 13. So you'll see that in just a few minutes. Roman numerals, which you may or may not have seen before, and non-metal prefixes, which is something that you'll use for ionic compounds and for covalent compounds. So that's something we're going to make sure that we take some time to look at. So let's do a little bit of flashback questions here. So first, let's talk about metals. We know that metals have a low ionization energy. And that tells us that it's easier to steal electrons. If it's easier to steal them, then we're going to lose them more readily. So our metals are going to produce cations. So it's kind of a clue there. The other clue is that it has a low electronegativity. So remember, that means it does not attract electrons. Both of those things explain to us why it's going to lose electrons, this one right here, and it's not going to want to gain any, this one right here, so it's going to form a cation. But remember, a cation is positive. So those are our metals. Our nonmetals, we're looking at pretty much the opposite of that. So nonmetals are to the right of our stair step. So remember, when we're looking at our periodic table, our stair step is right here, this darkened line. On the stair steps, my metalloids. To the left is my metals. To the right is my nonmetals. Okay, so that's going to be important as we start to move through this unit. So nonmetals here have a high ionization energy. Which means it's difficult to steal an electron. They have a high electronegativity. Remember, fluorine has that 4.0. It's the highest of the high, and that is a nonmetal. So it is attractive to electrons. And both of these things help us understand why nonmetals are going to gain electrons to form an anion, which remembers a negative ion. So metals versus nonmetals. And we'll get into metalloids when we get to non-patterns or specialty things. So you'll kind of see, especially group 14. I know y'all usually have questions about that one. So you will see that when we get to that section. So now let's go ahead and take a look. Let me move all this out of the way. And let's take a look at valence electrons. So valence electrons are in our outermost energy level. So we're working with those furthest on the outside. Pin out here. Oh, our electrons. Off the word electrons. Electrons in the outermost energy level. Remember, most elements want 8. We call that the octet rule. Oct means 8. If you think about an octopus, has 8 tentacles. And then these are the electrons that are gained, lost, or shared. To bond. So for this first part, we're mainly going to be talking about the gained and the lost part. Shared's going to be in our covalent section. Okay. So that's what we're going to be looking at there. Now, I know y'all are so excited because you've seen tons of these. And guess what? I told you they were going to be back, and it's back. So let's go ahead and take a look at our periodic table. You can pull one up from Canvas. You can get the one that we've made in class. You can look one up online, whatever you need to do. But let's go ahead and take a look at our periodic table. So the first thing it wants us to do is our valence electrons. So remember, I do group 1, 2, skip my transition metals, and pop back up at 13, where I just take my 1 off. So when I'm talking valence electrons, group 1 has 1 valence electron. And if we think about something like sodium, we're only touching 1 box in that 3s. That's its 1 valence electron, the only one that's in that outermost energy. But if I go to magnesium, I now have 1, 2. But say I wanted to do aluminum over here. I want my outermost, so I'm going to be looking at my 3s. So 1, 2, 3. Taking it to 14 right here. 1, 2, 3, 4. And that pattern continues. So 15 has 5, 16 has 6, 17 has 7, and 18 has 8. Now our next question is, what's going to be easier? Kicking X amount out or finding X amount more? So let's look at how that works here. Is it going to be easier for me to kick 1 out or find 7 more? Okay, I'm going to kick 1 out. If I kick out an electron, that's like me getting rid of negativity. If I get rid of negativity in my life, I have a more positive outlook. So I'm going to have a plus right there. Let's check out group 2. I can either kick out 2 or find 6 more. What's going to be easier? Right, we're going to kick those 2 out. When I kick those 2 out, I'm positive because I got rid of that negativity. And I kicked 2 of them out, so my charge is going to be a +2. Looking at group 13, I can kick 3 out or find 5 more. It's going to be way easier to kick those 3 out. Kick them out so I become positive, and I kicked 3 of them out. Now right here is where I usually get the most questions. So group 14 has nonmetals, metalloids, and metals in it. There's a lot going on in group 14. And because of that, they're kind of special. So for right now, for ion formation, they don't have a standard ion formation. So let's just put an X right there. It is not plus or minus 4. We'll see some things there that are going to be a +2, things like that. So I don't even want to put that down. So for right now, let's just skip on over that. Now let's check out group 15. I can either kick 5 out or find 3 more. All right, kicking 5 out is a little bit more work, so I'm going to find 3 more. If I take on electrons, I'm taking on negativity, so I'm going to be -3. When I get to group 16, my options are to kick 6 out or find 2 more. Right, I'm going to find 2 more. If I take in 2 electrons, electrons are negative, so my charge is going to be a -2. Now let's get to group 17 here. Kick out 7 or find 1 more. Well, dumb as I, sometimes easy. Let's just find 1 more. Perfect. Now group 18, it wants 8, so it doesn't really form an ion. Okay, or doesn't have a quote-unquote standard ion formation there. Now let's talk about what are, another pin out here. Examples would be from period 4. So, period 4 is going to be right here, starting with potassium. Can you see that? There we go. So, group 1, period 4, potassium. So, I'm just going to put my K. And it has a +1 charge. So, remember, my +1 is superscripted to the right. Now, you may see this written as 1+. I don't care which way you write it. Either way is fine with me. Then we're going to bounce to group 2, period 4, which is calcium. 1, 2, and its outermost energy. So we're kicking those out, and I'm going to have a +2 charge. Now, I want to go to group 13, which means I'm skipping this transition metal group. And you'll see why we do that here in a few minutes. But I'm going to get over here to gallium. So Ga. And we got a +3. Skipping group 14 because that's the one that has some iffiness. Okay. And we're going to move on to arsenic. Yes. -3, so up and to the right. Again, that superscript. Selenium, the -2 charge. And bromine with a -1 charge. And again, krypton wants to be neutral. It's one of our noble gases. So I'm just going to write Kr. By not putting a charge here, I'm telling you that it is neutral. So that's some review, some flashback, some putting details together from previous units to get us ready for this unit. So let's go ahead and take a look at our next page here, dealing with naming ions. So, pattern metals, we're going to be talking about, excuse me. So, pattern metals here are group 1, 2, and 13. Group 1, 2, and 13. So, only the ones that we just did on the front. And our method for naming these here is we're going to put the metal name plus the word ion. That's our whole plan. Metal name plus the word ion. So let's do a couple of examples. So I have K+. Now put this on here as a reminder as well, that if I put just a plus sign or just a minus sign, that means +1 or -1. So just keep that in mind. I usually personally write them, but if you see it written like this, just remember that that's a 1. So I have to say, okay, what is K? Look at my periodic table. K is potassium. It has a charge, making it an ion, so I'm just going to write potassium ion. Let's talk about Na. Na is sodium. It has a charge right there, +1, so it's sodium ion. Ca is calcium. Has a charge, so calcium ion. Now take a second, pause the video, and I want you to try these 3 over here. Okay, let's take a look at those. So Mg right here, that's magnesium. It's in group 2, so we can still just use that same naming. So magnesium ion. Al over here, aluminum, name on that, ion. And Li right here is lithium. And it's a charged particle, so we're going to put ion. That seems easy enough, right? Okay. So let's look at one where we have to do an additional step there. So this next group are called non-pattern metals. So what I mean by non-pattern metals are metals that don't fall into those nice pretty groups that we just did on the front page. So non-pattern metals for the most part are going to include our transition metals, and group 14. Now we will talk about some exceptions to this, but for right now we're going to focus on that entire grouping. Now the method for naming these is we're going to put our metal name, just like we did above. In parentheses, we're going to put the Roman numeral, okay, which I usually abbreviate just RN for Roman numeral. In parentheses, this is going to represent my charge, plus the word ion. So let's take a second to talk about Roman numerals. You may have used them before, you may not have. Either way, it's fine. We're going to talk about them right now. So my Roman numeral for 1, this looks like an I. Sometimes I will not write them with the little tops and bottoms on them, and that's totally fine too. If they're in parentheses, I will know what those are. Okay, so either way is fine with me. Roman numeral 2, got 2 lines. Roman numeral 3. Now Roman numeral 4 means 1 before 5. So 1 before 5. 5 is just a V. 6 is VI. 7 is VII. 8 is VIII. 9 is 1 before 10, so 1x. And then 10 is just an x. So those are things you will need to know. You won't have that necessarily as a resource to use generally, and it's considered a common knowledge piece. So make sure as we're working through this that you're practicing with some of those and getting used to seeing that. So let's look at some examples of what this is going to look like. So down here I have 2 different vanadium charges. Now there's lots of elements that have more than one charge, and if you look at the back of your periodic table, this entire row right here after the first 3 have more than one charge option. Those are going to have different types of reactions, different reactivity. They're going to behave differently because they have that different charge. You'll also notice that they're all metals, so all of these are positive. So that's what we're going to be working through when we are doing these charges. For this section, you're not calculating them. I'm giving them to you. But later on, we're going to work on how to calculate those. So, V is vanadium. So, right here. So, just like I did before, I'm going to go ahead and write the name. But this time I need to put my charge in parentheses. So this is a +2. So in parentheses I need to put my Roman numeral 2. It's just an ion. It's not in a compound. So I need to put the word ion. Now here's an example of the two ways you could write the Roman numerals. You're welcome to keep those lines, or you can just do the lines in the middle. I'm fine with either one. Now this is still vanadium, so that part's still the same. But instead of 2, my charge is now a 3. So I need to change that Roman numeral. That is what makes that different. Pause the video and check out those next 4 on the Your Turn and see what you get. Okay, let's check out the Your Turn answers. So, first thing we got to do is see what Cr is, and Cr is chromium. It has a charge here of 3, so in parentheses I'm going to put a Roman numeral 3, and it's just a charged particle, so I'm going to put ion. Fe is iron. It has a +3 charge, so in parentheses I'm going to put a 3, and then I'm going to write the word ion. Now Cu is copper, and both of these are copper, but this has just a plus sign, so I know that's copper 1. And I know lots of times people are like, oh, Miss Eisen, if it's just a 1, do I have to write it? Yes, you have to tell me that charge. So being specific there tells me that you didn't just forget to write something, that you knew it was copper +1. And then this last one is a copper +2 ion. So you've now looked at naming all of the metals. Awesome. So let's pop on down and talk about naming non-metals. Okay. So first thing is when it talks about our equation, I like to call it a method more than an equation. I'm just going to mark that out and put method. Is going to be us writing the non-metal root word plus IDE. So we're going to make this one word. Okay. So let's look at our roots. And if it's hard for you to see this, remember, check out the PowerPoint or Google Slides or whatever I have posted for you. Give those a look if it's harder for you to see on here, if my writing is not ideal. Okay. So basically, we're just taking off the endings. Nitride, ox, Lu. Please watch your spelling of fluorine. It is not fluorine. Okay. As you use these will become much more familiar to you, and some of them probably already are, but you'll definitely want this as a resource for you as we start working through them. Okay, so I've put down my root words. Just like if you've taken mythology or you've looked at prefixes, suffixes, these root words are identifiers that we can kind of change the endings on. So you'll see when we move into talking about polyatomic ions, like on here, I have sulfide, sulfate, sulfite. Those are all 3 very different things, but they all have the same root word. So how we're using that root word here is really going to matter. So let's check out this first one. This is sulfur. It's charged, so I need to show the world that it's charged by changing its name. So I'm going to put sulf and then add my ending of IDE. So that is sulfide. You all are probably used to things like chloride, sodium chloride. Okay, that's where this is coming from. Nitrogen with a -3 charge. So nitrogen. I'm going to put my root word in IDE. So I have a nitride. pause the video and try the 3 your turn ones. Okay, let's give those a look. So we have oxygen here, so I'm going to do my root word of ox, and I'm going to add my IDE. F right here is my fluorine, so it's going to be fluoride. And then my I is iodide, because I have my root word plus my IDE. So that is all for the naming of nonmetals. There's only one type of nonmetal, so you don't have to worry about working with anything else until we get to polyatomic ions. Give those a try. Whatever questions I may have on Canvas for you, give those a look and send me whatever questions you have.